Hi everyone. So first of all, how do we define a natural number? A natural number is an integer that is not negative. So for this question, we're trying to prove that the greatest common denominator of two numbers that are consecutive is 1. So for example, we're trying to prove that when you have two numbers next to each other, for example, let's say 34 and 35, that their greatest common factor is 1, or 3 and 4, their greatest common factor is 1. Seems obvious, but we need to be able to prove this. So how do we do it? Well, in this lesson, we learned that if two numbers have a common factor, then their difference also is a multiple of that common factor. So let's say our two numbers are n and n plus 1, the next consecutive number, and their common factor is d. So what's the difference of n and n plus 1? We would find that by subtracting one from the other. So n plus 1 is one number, we're going to subtract n. N will cancel out with minus n, and we're just left with 1. So 1 is their difference. So according to what we've learned today, 1 must also be divisible by d, the common factor. But the only natural number that 1 is divisible by is 1. Therefore, the greatest common denominator or factor, divisor, of n and n plus 1 is 1. That is part A. So for part B, we have to describe all the counting numbers for which the greatest common divisor is 2, and they must be two natural numbers apart. So we're looking at numbers such as 82 and 84. We're going to check if it works for numbers like 33 and 35. Basically, we're going to explore for which numbers that have two natural numbers between them is this true. So let's find out. How do we do this? Start off the same way as we did in part. So I'm going to make a question mark here because we don't know much about these numbers yet. So once again, we're going to assume that d is a common factor. D is a common factor of n and n plus 2, these two numbers we don't know much about yet. Then their difference is calculated by saying n plus 2 minus n. N's cancel out, and we are left with 2. Now we know that 2 must also be divisible by d, the common factor. What are the numbers that 2 is divisible by? 2 is divisible by 2 and 1. Therefore, the numbers that we're exploring, namely n and n plus 2, must also be divisible by 2 and 1. In other words, they must both be even. So this question here, this statement actually that we have here, is only true when n is an even number.